Hello, welcome. In this short video, let us look at how an LTI system processes a derivative of an input. That is, when a derivative of an input is sent into an LTI system, it gives out the derivative of the original output. That is, given an LTI system with the input x of t having a corresponding output y of t, then an input x dash of t, that is, if you give the derivative of the input x of t as an input, then the corresponding output is y dash of t, that is derivative of the original output. Now let us look at various ways to verify this fact. The first one is based on the definition, that is LTI system. That is when the input x dash of t, which is written as limit h tends to 0 x of t minus x of t minus h over h. That is, by using the definition of a derivative, we can prove that when the input is equal to x dash of t, the output will be y dash of t for an LTI system. So, and since this expression is basically a linear combination of x of t with x of t minus h, then the corresponding output will be, that is, when the input is limit as h tends to 0, 1 by h x of t minus 1 by h x of t minus h, that is a delayed version of x of t, then the corresponding output should be equal to limit as h tends to 0, 1 by h x of t will be replaced by y of t. This is the corresponding output. And then we have 1 by h y of t minus h. This is only true for a linear time invariant system. The expression on the right hand side can be rewritten as limit h tends to 0 y of t minus y of t minus h over h, which is by definition equal to derivative of y of t. Therefore, for an LTI system, the derivative of the input will result in the derivative of the output. That is, when the input is equal to derivative of x of t, the output will be derivative of y of t. We can also verify this result by looking at the convolution formula. That is, y of t is given by x of t convolution with h of t, the impulse response, which is equal to integral h of tau x of t minus tau d tau. So this is y of t. Now by replacing x of t with x dash of t, then the convolution of x dash of t with h of t is equal to integral h of tau x dash of t minus tau d tau, which is equal to integral h of tau d by dt of x of t minus tau d tau. So by writing the symbol d by dt outside, you can clearly see that this is equal to d by dt of integral h of tau x of t minus tau d tau, which is equal to derivative of y of t. That is, when input is x dash of t, the output is the derivative of y of t. Another way to look at this result is by using the block diagram. That is, the convolution x dash of t convolved with h of t is equal to x of t convolved with u1 of t, again convolved with h of t. This is based on the definition that x of t convolution with u1 of t is by definition equal to derivative of x of t. So, based on this definition, x dash of t convolution with h of t is equal to this double convolution, which can be written as x of t going through the system, the subsystem u1 of t, and then again going through the impulse response of the other system h of t, and the output will be y dash of t. Thus, for an LTI system, if the input is replaced by its derivative, the output should also be replaced by its corresponding derivative. Thanks for watching.